Okay, students, sorry, I was grabbing a table. This is number 16 on the worksheet. It is an example of a dependent sample, or otherwise known as a before and after study. It has to do with deer population in Colorado. And they've collected the average deer count for a 5-year period before the highway was built, and then for a 5-year period after the highway was built, and they have different wilderness districts. And they want to see if the population has dropped since this highway was put in. And we're going to use a 5% level of significance. So the first thing that we must do is, of course, calculate the differences. So we take the befores minus the afters and get a difference row here. Then, depending on if you're going to use a graphing calculator and do the p-value method, or if you're going to use a more traditional method like the critical value method, you might want to get your average of the differences and your standard deviation of the differences using one variable statistics or the super old school formulas. Now we need to set up our hypotheses. So H0 will always be the differences. The mean of the differences is 0, meaning there is no difference before the highway and after the highway. The alternative, they want us to test if the population has dropped, but we have to kind of think about what that means because it's very confusing and deceiving. Dropped, often you just want to put in a less than symbol, and I understand that, that instinct, but we have to think that we took the befores minus the afters, and a drop would indicate a positive number for the difference, right? So you have to think about it mathematically. Thus, we want a greater than symbol in our alternative hypothesis. Okay? Now, I'm going to do both the p-value and the critical value method kind of simultaneously. So the critical value method, people, if you're doing that method, you need a t. It's a one-tailed right with 9 degrees of freedom. So 10 minus 1 is 9 degrees of freedom. So, and alpha is 0.05. So it's a one-tail area, alpha is 0.05, and we scroll down to 9 degrees of freedom. So our critical value is 1.833, and it is positive because it is a right-tailed test, and this is our rejection region. If you're doing the p-value in your calculator, you would want to go to Stat, and you'd want to go to your testing menu, and you'd want to select a t-test, okay? So make sure that you're selecting a t-test, and then your mu0 is going to be 0, because that's what it is in the null hypothesis, and then make sure your frequencies are correct, and make sure you have the right alternative hypothesis selected. We're doing a right-tailed test, and then we hit to calculate because we don't want to draw it, and it'll give us our p-value right up here. So we would want to write that guy down, 0.004062. And then, of course, you want to compare that to alpha and base your decision on it. But test statistic, if you're back at the critical value, you guys have to do your test statistic to find out if you should reject or not. And like I said, you always come out with the same decision no matter what method you use. One method uses technology to help you find the answers, and another method uses technology as well, but it's a little less straightforward, more manually run your part. So when you do the test statistic, you should be coming out with 3.452, and as you can see, that does fall in the rejection region. And for the p-value, guys, p is less than alpha. Okay, so we are going to reject H0. And so that means, based on the evidence, the mean population is, or has, let's use the word has, significantly dropped since the highway was built using an alpha of 0.05. However, it's important to note that even though we're saying that the population has dropped, we can't say that it's because of the highway. We can only say the population has dropped and that's all. As far as what has caused the population to drop, that's someone else's job. As a statistician, you can only say, yes, there was a significant drop, or no, there was not. So it could have been disease, it could have been because, you know, they're getting hit by cars. It could be a lot of different factors, so we're not trying to figure out the factors. That's not our job. Our job is just to say it has significantly dropped or it has not. Okay, so just keep that in mind, and that's a before and after study for you.